Well, spring has finally sprung here in upstate New York. The birds are chirping. Well, at least the sun is shining. Okay, as I'm filming this, we've actually just been buried under feet of snow.
So today, since spring has decided to delay its arrival, I've decided to make spring myself.
Well, not exactly spring this season, but more like a spring animation in SOLIDWORKS. Recently, I wrote an article for the SOLIDWORKS Tech Blog where I used an example of my RC drift car's shock to create a flexible spring animation. I recently built a replica of Rob Parsons' Chair Slayer car and brought it with me to SOLIDWORKS World this year. I modeled the whole chassis in SOLIDWORKS as I built it, so I'm sure you'll be seeing more of this model than just the shocks. Now, I've seen all kinds of different ways to animate springs in SOLIDWORKS, and this method is a combination of a few of them that I've used in the past. I tried it completely on a whim, and I really liked how it behaves so far. What I like about this method over others and that I've used in the past is that it seems very stable, it rebuilds quickly, and it's very flexible, no pun intended, in its applications. Here are 4 examples I've done with variations of this technique. As you can see, this technique can be applied to create straight spring animations, curved springs, wave-type springs, or even bent springs of an odd shape like a firearm magazine spring. These were created directly out of SOLIDWORKS with no post-processing. So we'll walk through this method that uses an old surfacing trick to create interactive geometry in SOLIDWORKS. We have 2 components that move up and down. All we'll do is to simply create a boundary on each one of those components. That boundary will shift with each of the components, and we'll stick a part in between that will move with those boundaries. Now, the sticking point for this technique, usually in the past, was creating a helix that actually updates with those boundaries. And that's where our surfacing trick will come in handy. Let's check it out. So here we have the assembly partially prepped for this process, and you can see here that I've sort of allowed this assembly to have full range of motion, and it kind of stops when it gets to the end of its range of motion, which I've done with a width mate that's just been set to free. Now this isn't really required for this particular example that we're looking at, but I find it makes it a little bit easier to work with the assembly if it's somewhat limited in its travel and things aren't just completely sliding in, in and out of where they shouldn't be. So I set that up ahead of time just to kind of limit things a little bit. Now the way that this animation works is to sort of trick the SOLIDWORKS animation into acting like the spring is actually compressing. Of course, we don't have any actual deformation or any kind of mesh techniques that we can use in animation. But what we're doing is we're creating some geometry that will update on a frame-by-frame basis as it gets into the animation and look like the spring is actually compressing. So again, what we'll be doing here is creating a set of bounds up here and down here that will follow the locations of the components from within the assembly, and those will then slide up and down as we're driving them with the mate, which will drive the component, in this case our spring, in the middle. So let's start off by adding in a component. I'll go up to Insert Components and I'll say New Part. Now this new part is going to be our spring, and what we need to do is tell it where we want this spring to land. So I'll select a face on the bottom here, my bottom component, and that launches me into a sketch immediately. You'll see that we're in a sketch here, so we're immediately launched into Edit Part mode. So we're editing the part, our new part, in the context of the assembly, and we have a sketch already going. Now I don't need this sketch here, so I'll just exit this for the moment, and you'll see that that leaves me just in Edit Part mode. All right. Now from here, I notice that my external references are turned off, and I will need external references for this process, so I will uncheck that so we can track these external references. What we need to do now is to create this set of bounds here, which I will do with planes. Now planes you can find from Features, Reference Geometry Plane. I will often do this right from my S key, which you'll find as the default setting has the plane available. So I'll select this lower face here, all right, and this will be one of our faces that we'll be tracking. I don't need a distance. What we do want is coincident. So I just want to be right on top of that face for this lower spring perch here. So we'll say OK to that. And we'll do the same thing on the upper side. So I'll select my S key, hit plane, select this upper face, and again we want that to be coincident, and we'll say OK to that. All right, now from here, you'll see that we're still editing this part. If I expand this out, we now have 2 planes in here. This one's our bottom one, so we can rename these. And this one's our top one. Okay. Now, while I'm here, I will usually grab something as reference from the model itself. In this case, we have this edge here, which indicates where this spring needs to actually be. So let's create a sketch right on this top plane here. We'll create a sketch. Again, we're in the context of the assembly. Remember, we're still editing this part here, and we're looking for this edge reference. Now, what I'll do is I'll give this a little bit of offset just to give myself some room here. So I'll just use offset entities, and I'll select this guy here. We'll bring that down somewhere in the middle, and we'll say OK. All right, again, from here, we can exit that sketch. I'm doing that by using the breadcrumb shortcut D key. And we're back into edit part mode. Now, at this point, we basically have everything that we need to sort of get this process going. I find it a little bit clumsy to work from within the context of the assembly, so I'll usually move back into part mode where I can see it in its own window and just kind of work independently. That way I don't have all the other components in the way. So I'll do that at this point. And from here, we can exit edit part mode. Again, I'll also do that with my D key, or we can move up to the confirmation corner. So at this point, it doesn't look like much has happened. So let's go ahead and we'll open this part here. While I'm here, I'll give this part a name. We'll call that spring. And we'll open it up in its new window. Okay, so here we have kind of a labeled set of references for this component here. So I've got nothing but a sketch on the top and a plane on the bottom. And I know that when this assembly is in motion, these 2 planes will be moving up and down based on the component's locations where the spring needs to mount up against. All right, so I have some kind of advantage here from within the part that I know these are going to be in reference, the locations of these planes are in reference to where they are in the assembly. So that's usually the tricky part here, because when we're making a spring or something of that shape, oftentimes we're using a helix or something like that that doesn't really give us easy access to adjusting the length or the height of something like that. So what I do instead is I use a little surfacing trick, and I'll use an extruded surface that allows me to easily go up to some kind of reference, and I can use this plane as that reference. So let's see how that works here. I have my surfacing tab turned on, but again, if you don't, you can right click and turn on any tab you need. And from the surfacing tab, I'll select extruded surface, and I'll take this reference that I already have created, and I will go up to reference, which is this bottom plane. Now I've just double clicked on my bottom plane because it's shown, but you could also select the drop down, say up to surface, and select bottom as the reference. From here, we can say OK. Now at this point, it still doesn't look like we've done much of anything because we haven't. But what we have created is this adjustable height cylinder that will move up and down and scale. And we can intersect this with something that will give us some kind of reference that will shift up and down. And that's exactly what we'll do here. In order to create this geometry, I'll actually create a sweep that creates the helix itself. This is really the crux at this point of the surfacing trick. So let's create a couple of sketches here in order to make this work. From our top plane, I'll select a sketch. And from here, I want a sketch that lasts from here all the way down to the bottom. And again, that will be kind of scaling because of the auto relations that will be applied. So I'll select my S key and I'll select line. From here, I'll go from the origin and we'll go right down vertically to this bottom where we're getting our auto relation of coincident. Okay, so the height of this line is now driven by the distance between the 2 of these planes, another critical element. From here, we'll exit the sketch. That's all we need for now. And at this point, we can create something that will actually generate this shape. So on my top plane, I'll select sketch. And again, we'll use just a single line. From here, we can go out. We can end directly on this or go past. I'll end directly on here in case I want to change the diameter of the spring. Now with these two single lines, we'll actually generate the helix. So let's move up to a swept surface, and I will sweep this line along my new center line. Now remember, this center line is scalable. From our options, we can choose specify twist, and we can set how many revolutions we'd actually like this to twist. So here is how many coils will be in our spring. Say we need 5 coils, and we'll say OK. Now we have our helix, we have the diameter of the spring itself, and all of that is scaling up and down based on the locations of the two of these planes. So from here, we can intersect these two shapes, and that will actually result in a sketch. To do this, I'll use the Intersect Curve tool. I find the easiest way to access the Intersect tool is to use search commands. I'll hit S on my keyboard, which brings up the shortcut toolbar. It will also launch me into search commands at the top right of the screen. I will select intersection curve, and we'll choose the two surface bodies. From here, we'll say OK. We'll close out the intersection curves tool, and you can see that has generated a 3D sketch which traces where the two of those surfaces intersect. At this point, I don't need these two surface bodies, so I can select the two of these and hit delete. From here, we can use delete bodies. We'll say OK, and that puts a feature in my tree that deletes the two surface bodies that I just used as reference. All right, so now we've got something that looks fairly spring-like. We've got a helix. It's adjustable in its height based on the two planes that we've set for top and bottom, and we've controlled the diameter of the spring by the sketch that we've created in the context of that assembly as well. Now, all we've got to do is create the geometry for the spring itself, which is as simple as moving back to Features, going to our regular sweep, not our surface sweep, but our solid sweep, and selecting Circular Profile. From here, we can choose our path, and we can choose our size, and we'll say OK. That's looking pretty good. Now here, I just want to trim off the remainder from the top or from the bottom. I could have extended this further if I wanted to with some offsets. In this case, I'll just trim off a little bit from the top and the bottom. To do that, I'll actually go right back to my surfaces, and I'll use the same planes that I used to generate the geometry as I will to trim them. So here we'll use Cut with Surface. I'll select my plane as the reference. My direction is facing up, and we'll say OK. Likewise, on the underside, I'll say Cut with Surface. I'll select the bottom plane. My direction is facing down, and we'll say OK. At this point, I can hide the two planes. And we'll move back to the assembly. At this point, I'll save. We'll say Save All. And I've been prompted to save externally or save internally. Remember that we created this spring from within the context of the assembly, so it has not been saved as its own individual part yet. I'll say Save Externally, put it with the rest of the components, and we'll say OK. Now we're on the home stretch. Here we can apply an appearance. Let's give it a high gloss plastic. And now when we move our components, we should see this update. Now from here, all we have to do is drive the distance between those two components and set that into an animation. So I'll return back to my mates, and again, I will suppress the mate that I have that's controlling the distance at the moment. So I'll suppress my width mate, and we'll add in a new distance mate here. I'll select the two components that I'm interested in controlling, and we'll select distance. From here, I can set a value. We'll give it, say, 30. We'll say OK. That will be the bottom position. Now, I find the easiest way to control these things is with the mate controller. So I'll come up to the top in my mate controller, and I'll turn it on. And we'll choose what mate we'd like to control. This mate is our new distance mate. From here, we'll create some positions. We'll call this bottom. And we'll say OK. And we'll create a new position called top. And for top, we'll set a distance of something smaller, say 15. Okay. Now I notice that my component has moved down, which is not what I wanted. So we'll go back and we'll add in a coincident here, just to make sure everything is moving in the right orientation. And now we see that it is. So that may be a little much. Let's go back and make an adjustment here to our mate controller. Let's call this a 20. For the top position. And we'll update. That looks a little bit more reasonable. And now we can adjust with our mate controller what position we'd like to see. Whether the shock is down in the bottom position or up in the top position. Now the benefit of this is twofold. One, we can easily control those positions up or down. But two, I can easily import this as well into an animation. So let's do that now. We'll move down to our motion study one, and we'll go right to the animation wizard. From the animation wizard, I can set my mate controller to be imported. Here we'll say next. I can set these as key points. We'll say next, and I can set a duration from where I want this to start. 0 to 10 works for me, so I'll say finish. Now from here, we're going from one position to the other in my mate controller. One additional thing that I would like to do is set this up as a camera. I find that's the easiest way to control the aspect ratio as well as the view of our animation. So let's do that now. We'll go over to our display manager and we'll select from scenes, lights, and cameras. We'll right click and say add camera. From here, I'm saving this for the web. So I will set this as an aspect ratio of HDTV format, 16:9. From here, I can choose what type of camera I would like. That looks halfway decent. We'll say OK. Now for my orientation and camera views, we can select camera view. Since I only have one camera, it snaps right into my single camera view. If we had multiple cameras, we would be prompted with a display that asks us which camera we'd like to use. Now from here, we're ready to go. So I can save this animation out. Again, I've set its size, fixed aspect ratio, using the camera aspect ratio, exactly what I want. We can set how many frames per second we like. I use 25 as the minimum. We can give it a name. Shock assembly sounds fine to me, so I'll hit save. And from here, we can choose what type of compression we'd like to use. I choose to use full frame, typically when I'm saving out as an AVI, as I'm generally putting these in some other project that I export as a MP4 anyway. So I save this as large as it can with as little compression, and then I let it get compressed with the MP4 with everything else. So I say full frames and say OK. At this point, it asks me to update the motion study. I say yes and allow it to calculate, and it will run through the motion study, updating each location, and save that out. And that's all there is to it. As I mentioned, one of the things that I really like about this technique is that it's very flexible. For example, here we've created the same effect but with a curved spring. And if we look at the technique for this, it's essentially the same. Here, rather than use an extruded surface, we've just used a sweep. But you can see the technique is essentially the same. So sweep along the curved path and twist along the rest of it, intersect the two, and there you have your spring path. Likewise, with something like a wave spring, a similar technique can be used. Here I've intersected surfaces where the style splines are adjustable. Here we see a segmented line is now driving the heights of splines, which is driven off of the length of the extrusion, which is driven off the planes from the assembly. Again, it doesn't matter what the shape. In this case, our spring is not round. Here we can see it's still just a combination of surfaces. In this case, rather than a surface extrude or just a standard circle swept along a path, it's now a more unique shape swept along a path and then intersected with our helical surface. So with this process, you can animate a wide variety of different flexible-like shapes. So that's my method for creating flexible animations in SOLIDWORKS. I'd love to know what you think in the comments, and if you created anything cool using this technique, I'd love to see it. Please send it my way.